Lesson 10 is solving linear systems by graphing. So this is our first kind of experience with linear systems. We're going to talk about them more in the next unit, but I think graphing is kind of a good way to introduce them. So 10.1 is graphing a system of linear equations. So a system is two or more equations put together. So if you'll notice, like the example in 10.1 says graph the system and find the solution. And then if we look at the system, this is the system, there's two equations there. So a system has more than one equation put together. So if we want to graph them, we need to find the slope and the y-intercept of each line. So both of the equations in 10.1 are in slope-intercept form. So that's like our y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so if we look at the first equation, so y equals negative 1/4 x plus 2. To find the slope, we look at the number that's being multiplied by x, so that's negative 1/4. And then to find our y-intercept, we look at the constant term, which the constant term is the number without the variable being multiplied by it, so ours is 2. Okay, so when we graph lines, we put a point on the y-axis for the y-intercept. So since our y-intercept is 2, we're going to go to 2 on the y-axis and put a point there. And then to get to our next point, we only need 2 points because it's a straight line. So then like 2 points to connect it and the rest of the points will fall on the line. To get our next point, we use our slope. So I'm just going to kind of rewrite it up here. M equals negative 1/4. And then remember that slope is rise over run. So that's kind of like the formula that we use on the graph. So rise over run. So if my like rise in the numerator is negative 1, that means I'm going to go down 1 because it's negative. And then my run is 4. So I'm going to go to the right 4 because it's a positive 4. And then notice our slope was negative, so there's this negative sign here. It was in front. I put it on top. It needs to go either in the numerator or the denominator, not both. So you just put it on top or put it on bottom, but only in one place. So since my rise is down 1, from my initial point, I'm going to go down 1. And then my run is 4, so I'd go right 1, 2, 3, 4, and put a second point there. And then those 2 points are enough. I can connect them now and have my straight line. So I'm gonna start here. I always like, you have to be so careful to make sure it keeps going like straight through the like correct points. It's really easy, even if like you have paper and a ruler, to get them like kind of offline, and then it messes it up a little bit. So that's why I was going so slow, just to make sure it's like going only like in this case I'm going up 1/4, up 1/4, up 1/4. You don't necessarily have to be this careful every time, but just to be safe. Especially when you're dealing with a system, it's like really important that you graph the lines accurately, and I'll explain why once we kind of get to our answer part. Okay, so my first one that was in purple, so I'm gonna leave that highlighted just so we can tell the difference. And then before I move on to the second line, remember that like for slope, just kind of like as a way to check your work, slope, we read it, the graph from left to right. So if I read this graph from left to right, it's like going downwards, so that means it has a negative slope, and my slope was negative, so it kind of matches up. So it's just kind of a way to check your work really quickly before you move forward. And then for the second equation, so y equals 3x minus 11. If I find my slope, that's the number that's being multiplied by x, so that would be 3. And then b is the y-intercept, that's the constant term, so it would be a negative 11. So we have to make sure that we include the negative with the 11. So b is negative 11, so I'm going to put my first point at negative 11 on the y-axis. So the b number always goes on the y-axis, so that's all the way down here. And remember, the y-axis is the vertical one, the one that goes up and down, and the x-axis is the horizontal one. So I have my first point, And then I use m, my slope, to get my second point, so it'd be m equals 3. And then we usually think of slope as like a fraction, so I can make this a 3 over 1. And then same thing as before, we'll do rise over run. And then my slope was a positive 3, so I don't need to like add a negative or anything like that, just they both stay positive. So if my rise is 3, I'm going to go up 3 since it's positive 3. My run is 1, so I would go right 1 since it's positive 1. So I would go up from negative 11 up 1, 2, 3, and then right 1 right there. And put my point, and then I just need the 2 points, and now I can connect them. I just want to be really careful that I am connecting them like straight through. So like I went 3 up 3 over 1, up 3 over 1 again, up 3 over 1. Trying to be really careful. I think I messed that one up. Okay. There we go. I think that's about as close as I can get it. So the reason that we do want to be so careful when we're graphing our lines to graph them straight is because when you are solving a system by graphing, we are looking for the intersection point. So we're looking for this point right here. So we just want to make sure that we're not like off from our points by like a tiny bit, because that really can skew the graph, especially like the further away you get from your original points. So we're looking for our intersection point, which is right here, and that point is, I have to go to 4 on the x-axis, so the x-coordinate is 4, and then I go up 1 to get to that point. That's our solution to the system. So that's the answer that we would be looking for. So the question solve this system is 4, 1. And then from there, we can always like check our solutions. So in order to check our solutions, we take that 4, 1, and we put it back into the equation to see if it makes it true, which means like it makes each side equal basically. So my first equation, that was y equals negative 1/4 x plus 2. And if my solution was 4, 1, 4 is the x coordinate, so I would put 4 in for x, and then 1 is the y coordinate, so I would put 1 in for y. So then this would turn into 1 equals negative 1/4 times 4 plus 2. And then I would multiply negative 1/4 times 4. And if I multiply negative, like a fourth of 4, and like of usually means multiplication, is just 1. So if I multiply those two together, negative 1/4 times 4, that would be negative 1. And then bring down the plus 2. And then bring down my 1. And then on the right side of the equal sign, negative 1 plus 2 is positive 1. So that equation is true because we got the same number on each side. So that checked worked, and then we just want to check the other one also. So the second equation is y equals 3x minus 11. So same thing, our x coordinate from our point was 4, and then our y coordinate from our point was 1. So we would put 4 in for x, and then we would put 1 in for y. So it'd be 1 equals 3 times 4 minus 1. Oh, I forgot, sorry, this is an 11. I didn't copy the equation, right? Excuse me. It was supposed to be 3x minus 11, but I just put a 1 there instead of an 11, so I'm just going to change that to an 11. And then the next thing we can do is go ahead and just multiply 3 times 4, so it'd be 1 equals 3 times 4 is 12 minus 11. We'll just keep copying down that 1 equals part, and then 12 minus 11 is 1. So that checked worked also, so that just confirms that we got the correct answer. Okay, so biggest thing to pull from section 10.1 is that when you graph two lines, the intersection point is the solution to the system. Okay, so moving down to 10.2. So finding the solution graphically, so in this case, like we're already given the graph, the first thing that we want to do is analyze the graph and write the equation for each line. So I'm going to kind of separate this by color since one of them is in red, one of them is in blue. So the red one, and if we kind of take a step back, actually, the like situation given in this graph is it's a supply and demand graph for, looks like a muffin shop or a muffin factory. So you could see like on the x-axis, it's price per muffin in dollars, and then on the y-axis, it's like the weekly number of muffins that they sell. And the two different lines are showing like the demand for it, and then the blue line is the supply for it. So we'll talk a little bit more about that in the second part of this question when we interpret the solution. So for now, we want to write the equation for the line. So I'm going to do demand first. I'm going to write these in slope-intercept form, which is y equals mx plus b. I would say that that's usually like the most common way that we write equations of lines. So I know we've talked about like slope-intercept form, point-slope form, and standard form, but usually slope-intercept form is the most common one. So we need two things to write in slope-intercept form. We need m, which is the slope. We need b, which is the y-intercept. Usually the y-intercept is easier to find. It's just looking at what number is our graph crossing the y-axis at. So if we look at our graph for demand, it's starting right there on the y-axis at 80. So that means that our y-intercept is 80 and b is 80. And then to find the slope, I need to figure out rise over run. So remember, when we look at a graph, slope is rise over run. I just need to pick any 2 points on this graph to calculate it. So you want to pick like exact points. So for example, I wouldn't want to use this because it's like kind of in the middle. I don't exactly know where it is. So I'm going to use this point and this point to calculate my rise over run. And you can pick any 2 points that you want. So for the rise, I'm going down from 80 down to a height of 70. So my rise would be -10 since I'm going down by 10. And then for my run, I'm going over from like an x coordinate of 0 because it's like right on the y-axis. I'm going over to 0.2. So I'm going from 0 to 0.2. So then this would become a 0.2 right here. And then from there, we can just go ahead and divide. So we could do -10 divided by 0.2 is 50. So it would simplify to -50. -10 divided by 0.2 is -50. And then that's all the information we need to write the equation of the line. So we would just take those and put them in for m and for b into y equals mx plus b. So altogether it'd be y equals, we put m first and m is -50. And then x and then plus b, so plus 80 was what we found for b. And then the second line is for supply. So we just repeat the same exact process. We can find b first, which is where it crosses the y-axis. So you can see it crosses at 0, 0. So b is just going to be 0. And then after that, we need to find slope. So we'll do rise over run. So my rise, you just have to pick 2 points only. So I'm going to pick this point right here and then this point right here. So my rise, I'm going from 0 up to 10. So my rise is 10 and it's positive this time since I'm going up. And then my run, I'm going from x equals 0 over to another like x equals 0.2. So my run is 0.2. And then now if we do 10 divided by 0.2, that would be positive 50. So they're almost the same slope. One is just positive, one is just negative. You can kind of like, not that you would be able to like guess this from looking at the graph, but it makes sense just based on like kind of the angles of the lines are really similar. One is just going up and one is going down. Okay, so we have m, we have b. We can plug them into y equals mx plus b. So it'd be y equals m was 50, x, and then plus b, so plus 0, but we don't need to write plus 0 because it doesn't make an impact on like the value of the equation. So our two equations are y equals -50x plus 80 for the red one, the demand, and then y equals 50x for the blue one, the supply. And then for the second part, for find and interpret the solution, so we're looking for the intersection point, which is right here. That point is at 0.8 on the x-axis, and then it's at 40 on the y-axis. So it's the point 0.840. And then interpret means describe what it means in the context of this problem. So don't just tell me it's 0.8 on the x and 40 on the y. We have to relate it back to like the muffins that are being created. So we have to look at what each axis represents. So the 0.8 is on the x-axis, which is price per muffin in dollars. So $0.8 means 80 cents. So this means that it's 80 cents. And then the 40 on the y-axis, that's the weekly number of muffins sold. So 40 muffins sold per week. Usually we use like a little division symbol. It means per, like kind of shorthand, so per week. And then we just kind of want to put it all together like you would like a word problem and kind of write your final answer out. So we can say when muffins cost 80 cents, they sell 40 per week. So when muffins cost 80 cents, they sell 40 per week. And then moving down to 10.3. So 10.3 is about like special types of solutions. So we've talked about where, I'm going to go back up really quick. So the solution is always the intersection point. Like our solution for this graph was 0.8 and then 40. Our solution from 10.1 was the 0.41. It was where it intersects. Because these are both straight lines, there can't be more than one solution because like the lines are going to like curve back to each other. There would only be one for a linear equation or a linear system. Remember, linear just means straight lines. So if we go to 10.3, there's two special situations where you could have either no solution or infinitely many solutions. So the first one, no solution, we're going to graph these two equations. So the first one, y equals 1/3 x plus 6. So m is 1/3, b is 6. So remember, b tells us, and we're comparing this, I'm getting these variables from the y equals mx plus b still. So b is 6, that tells us where to start on the y-axis. So I go on the y-axis to 6 and I put a point there. And then the m tells you like what direction and how far to go to get to your next point. So since m is 1/3, it's positive. So it's rise over run. So if m is 1/3, that means my rise would be 1 and my run would be 3 because rise on top, run on bottom. So from my initial point, I would go up 1 and then I would go right 1, 2, 3, and that would tell me where to put my next point. So I'd put that right there, and then I would connect those 2 points. And then we just repeat that process with the second equation. So the second one is y equals 1/3 minus 1/3 x minus 2. So m is 1/3, b is -2. So that means that I go on the y-axis and I put a point at -2 this time. And then my slope is the same. So it's m equals 1/3. So rise on top and the numerator is up 1, run is right 3. So from my initial point at -2, I would go up 1 and I would go right 1, 2, 3. So that'd be where I put my second point. And then from there, that's enough. I can go ahead and connect them. And then you can see like there's no intersection point, and you can also kind of tell by the graph that these are parallel. So when two lines have the same exact slope, they are parallel. This is really important to know because the angle of the graph or the angle of the line is essentially the same. So if their slope is the same, then there's nothing that's ever going to cause these two lines to cross paths because they're always traveling like at equal distance from each other. So if they're never going to cross paths, then there's not going to be an intersection point, and if there's not an intersection point, there is no solution. So this is no solution. Okay, and then the second problem, this is the last one for today. The other situation is called infinitely many solutions. So when there is, well, what it sounds like, there's infinitely many, there's as many as possible. So the first equation, actually both of them, sorry, those are no longer in slope-intercept form. So they're in standard form, which is ax plus by equals c. Standard form is not so important that you have the like formula memorized because we don't really pull the variables from it as much. Um, we'll find the intercepts to graph them, but before I get started with that, just kind of know that if you want, like if you really prefer graphing slope-intercept form y equals mx plus b, both of these equations can technically be changed into slope-intercept form if you want to. So I'm thinking I'll find the intercepts for one and then do slope-intercept form for the other, just to kind of compare what these two processes look like. Okay, so if I want to change something into slope-intercept form, I need to get y by itself. So if I look at the two equations, I already noticed that this y is almost by itself. It's just 1y versus this is a 4y. So if I were to change one of these equations to slope-intercept form, this would be the easier one. So I'm going to do that. So I'll just rewrite it up here. 1/2 x plus y equals 1. If I want to get it in slope-intercept form, I need to get y by itself. So that 1/2 x is being added to it, so I'm going to subtract it over. So minus 1/2 x minus 1/2 x right here. And then 1/2 x minus 1/2 x cancels out. I bring down my y. Slope-intercept form is y equals mx plus b, so it has the mx part first. So I'm going to write this negative 1/2 x first, and then plus b, so this is a positive 1, so I would do plus 1. And then now I can see, okay, m is negative 1/2, that's what's being multiplied by x, and b is 1, that's my y-intercept. So I'm going to go to 1 on the y-axis and put a point there. And then my slope is negative 1/2. That tells me how to get to my next point. So notice I just put like just the negative 1. If you wanted to, you can make the 1 positive and the 2 negative for your rise over run, but I usually just put the negative in the numerator. So if my rise is negative 1, that means I have to go down 1 since it's negative, and my run is 2, so I have to go right 2. So I would go down 1 and then right 1, 2, so my next point would be right here. Okay, and then I can connect those points. That's enough to go ahead and connect them. And then I can graph my second line now. So I'm going to go ahead and graph 2x plus 4y equals 4. This one I'm going to graph by finding the intercepts. That's one of the main ways that you graph equations that are in standard form. So in order to find, let's say we want to find the x-intercept first. In order to find an x-intercept, you have to plug in y equals 0. So this is something like we talked about in the video, like it's something that I would keep handy like in notes so you can reference back to it. So we would put 0 in for y into the equation. So it'd be 2x plus 4 times 0 equals 4. And then 4 times 0 is just 0, so that doesn't mean anything, so I can just cross it off. And then 2x equals, I bring down my 4, and then I'm trying to solve for x, so I'd have to divide both sides by 2. And then 4 divided by 2 leaves me with 2. So that's my x-intercept. So then I can go to my graph and I can put a point on the x-axis since it's the x-intercept. So that would be right here. And then I have to repeat that process with the y-intercept, except for it's just the opposite. So instead of plugging in y equals 0, I would plug in x equals 0. So I would take x equals 0, put it right here in the equation. So it'd be 2 times 0 for x plus 4y, I just leave y there this time, equals 4. 2 times 0 is just like 0, so it doesn't make a difference. I can cross it off, and then I bring down my 4y equals 4. And then from there, I'm trying to get y by itself, so I would divide both sides by 4. And then 4 divided by 4 is 1, so I'd be left with y equals 1, and that's my y-intercept. So I would go on the y-axis, and I would put a point at 1, and then I could connect those 2 points. And if you notice, like, this is just overlapping the line that we already had there. So that means if the 2 lines overlap, that means that there's infinitely many solutions because the solutions are intersection points, and every point on this line is an intersection point. So all of these points, like right here, right here, right here, right here, every single point where they connect, like the whole line essentially, is considered a solution. So we would just say infinitely many solutions. And we're like typing most of the time and stuff, so it's hard to find the infinity symbol, but if you're ever like writing it out, you can always shorten the infinitely with like the little infinity symbol like that.